Alright everyone, here we are in another video, this time 6.3, solving trig equations with multiple angles. What we're going to be focusing on now is, instead of just thinking of a single angle, we're going to be talking about, as you can see right here, double angles, triple angles, and then down below that you can't see at this point is a half angle. Okay, so we've already talked about sine of x equal 1/2. We're not going to go through this 100 times. We already know that this is 30 degrees and 150 degrees. That's what happens when we talk about sine being 1/2. These are the two angles that produce a 1/2. But what are we talking about if we're doubling the angle? When would that make it 1/2? Well, graphically speaking, I've got it pulled up here. I've got sine of x, sine of 2x is the black curve, and y equals 1/2 is the red line. We can see the intersections 1, 2, 3, 4 of them up until the 360 mark, which is right there. So there's 4 possibilities. Well, this only produced 2 possibilities. Now we've doubled it to get 4 possibilities. But how do we do that? Well, looking down here, we're going to be changing the restrictions when we solve these problems. When we write our answer, we are going to revert back to 360 degrees, but depending on if we're doubling, tripling, or cutting the angle in half, is going to change that restriction. So for right now, what I want us to do is I want us to talk about sine of x equaling 1/2. So there's my theta, there's 1, there's 2. And we also know it at 150 degrees, which is over here. Here's theta, there's 1, there's 2. Now we already know that sine is 1/2 at 30. I'll just make a note of that over here. And 150 degrees. So this is the one where it's 30. And this is the one where it's 150. Well, going all the way around, I make 360 degrees. That's what happens with this line. That's 2 pi or 360. But since I'm doing a double angle, it means that I can change the domain to being 720. So I can go around a second time. Well, by doing this, this is going to generate the other 2 angles. If I already went around once, I'm at 360 degrees. If I continue to go around, I now have to add the 360 and the 30 degrees, since I went around once and continuing around again. Well, 360 and 30 gives me an angle of 390. Well, now I continue around again. Now from 360, I'm continuing all the way till I hit that 150 mark. So I add 360 and 150. I'm just going to do that quick addition right here. 0, 1, 1, 510. Well, I've changed the domain, but they want my answer between 0 and 360 degrees. So let's think about this logically. 30 degrees. How can I make 30 degrees? What number can I plug in to make it be sine of 30? Well, I could plug 15 in. 15 times 2 makes 30. What if I wanted to make 150? Well, 75 times 2 is 150. That fits within this restriction. What if I wanted to make 390? 195 times 2 is 390. That fits in within this restriction. Making 510, I can put the number 255. 255 times 2 is 510, and 255 falls within this range. So what you're going to see is that when we're solving for a double angle, we're going to make the number of trips around the unit circle that's given here. So since it's 2, I went around twice. Once to be 360, twice to make 720, which you see down here. And then we're going to cut all of these in half for a double. For a triple, we would divide them by 3. So that way we can fit all of these original angles inside of our 0 to 360 domain. So I'm not going to take the time to write them on the blank, but these are your 4 answers. Now, I'm going to go ahead and from this point continue. So we already know we've got 30. We already know we have 150. We already know we have 390. We know we have 510. So we've went around twice. Well, now I want to do side of a triple angle, 3x. It says I can change my restriction to be 1080 degrees. So that means I can go around a third time. And then I would cut the angles in thirds. So I'm going to make a change right here. We went around twice. That means we're at 720 now. Now I'm going to go around for my third. So 720, add the 30. That gives me 750. Keep going around. 720, add the 150. It's going to be 870. Now, to fit it within our 0 to 360, since we're talking about we went around 3 times, we're going to cut these in thirds. So a third of 30 is 10. A third of 150 is 50. A third of 390 is 130. A third of 510 is 170. A third of this one, that's 250. And a third of the last one is 290. Now, just to double check us, if I were to change this to a 3x, notice that it has shrunk horizontally, and I've got 1, 2, 3, 4, 5, 6 angles before the 0 to 360 mark. Okay. Now you're probably thinking, okay, so for 2x and 3x, I cut them in half or in thirds. What about the x over 2? In the x over 2 case, which is detailed below, but we might as well look at it while we're up here. What if I wanted sine of x over 2? Well, we already know that it's 30 and 150. That's when regular sine is. In this case, instead of cutting them in half or cutting them in thirds, we double. So, instead of 30, I'm talking about 60 because 60 divided by 2 would give me 30. 150, we're going to double it. We're talking about 300. Because 300 divided by 2 would give me the 150. Okay. So moving down, what value in the equation causes the change? We already talked about it. It's this number here. Why? Because it is changing the period. Remember that trig functions function on a period, meaning that sine of x, it takes it from 0 to 2 pi before it begins to oscillate again and replicate itself. By changing these numbers here in the middle, we're changing that period, making the function either happen more times within that given period or less times. Okay, so looking at the picture, when I go from sine of x, I have 1, 2 times, to 2, now it happens 4 times, to 3 happening 6 times, and if I say 10, you can see that it's replicating itself multiple times within that little bitty time frame. So by affecting the period, we affect the number of answers that are possible. So now what we're going to do is we're actually going to solve some equations that are not sine, not all of them anyway, one of them is different. And when we do that, we're going to do the same process. We're going to think of it in the going around the circle however many times, and then revert it into fitting 0 to 360 degrees. Okay, so we're going to start with cotangent. So cotangent of 3x is equal to root 3. So what I want to really know is what angles of cotangent x without the 3 is equal to root 3. Remember also that cotangent is equal to the adjacent over the opposite. And we're talking about positive, so it's going to be here. We need root 3 over 1. And we also need it down here. Negative root 3 over negative 1. So here, opposite of 1 is always 30 degrees. So I know it happens at 30 degrees. And then here, if I'm at 180 and I add 30 degrees, that's 210 degrees. Well, now let's apply the 360. So we went around one time. Let's go around. Let's say this one is 30. Let's go ahead and say this one is 210. So now I'm going to go around a second time. And since we're talking about 3x, we're going to go all the way till 1080, which is 3 times around. So second round, 360 plus 30, that's 390 degrees. 360, and it goes all the way to 210, so let's add 360 degrees to this. 0, 7, 5. So 570. So we've been all the way around a second time. Now we're at 720. We're going to go around a third time. 720 plus 30, that's 750. And 720 plus 210, 930 degrees. So we run around 3 times. And now we have to cut these in thirds. So, cut each one of them in thirds. We're going to get 10 degrees, 70 degrees, 130 degrees, 190 degrees, 250 degrees, and finally 310 degrees. And that would be all the angles within this period that will give me the answer. All right, number 2, we're going to get it all in one trig function first. So I'm going to add sine of 2x over here. So I have 4 sine of x is equal to 2 divided by 4. We get that sine of 2x is equal to 1/2. Now, as we already did, sine of 2x is 1/2 above. I'm not going to go through it again, but this is how you get it set up to begin. Going through the next one, I'll actually work that one out. All right, solving this one, we're going to subtract 2. So we get 4 sine of x over 2 is equal to 2 divided by 4. So I get sine of x over 2 is equal to 1/2. Now, we also did this one above, but go through it one more time. When is sine of x equal to 1/2? We know this to be 30 degrees and 150 degrees. Well, since we're talking about a half angle, we have to double, which means that x can be 60 degrees, and it could also be 300 degrees. Number 4, set up similar. This time when we solve, we get that sine of x over 2. If I subtract 2, I get negative 4. Divide by 4, I get negative 1. Well, let's think. When is sine of x equal to negative 1? That's a quadrantal angle. It's this one right here, which means that x would have to be 270 degrees. Well, if I double this, that's going to give me 540 degrees. But that does not fit within our range. Therefore, this one is not possible. Okay, here, sine squared x over 2. All that means is that we're writing it looks a little different. We're really saying sine of x over 2 quantity squared. And we're going to take the square root of both sides. So I get that sine of x over 2 has to be equal to plus minus root 3 over 2. And in this case, we're writing them in terms of 0 to 2 pi. So we think when is sine root 3 over 2? Well, we know one of them right here, root 3 over 2. And the other one would be right here. So we're talking about sine being positive, first off. So this is if it was positive. All right, opposite of a root 3, we always know is 60 degrees, which is pi over 3. So we're talking about radians. Here, if this one's pi over 3, and now I'm in second quadrant, and this is pi. Pi subtract out of pi over 3 leaves me 2 pi's over 3, or 2/3 pi. So that's for the positives. What about if we're talking about it being negative? So now this is going to be the negatives. Down here, we have theta. We have negative root 3 and 2. And down here, I have negative root 3 and 2. Well, if I'm at pi, and then I add another pi over 3, since we do know this is still pi over 3, that means I'm at 4 pi over 3. Similarly, if I'm over here, this is 2 pi, and I'm below that mark, it means I take away pi over 3. That leaves me 5 pi over 3. Now, according to this being actually a double angle, we have to double all of these. So that means I really have 2 pi over 3, 4 pi over 3, 8 pi over 3, and 10 pi over 3. Now, I wonder, do you see the problem? This one works. This one works. But these two do not, because they are outside of this range. So only these two work. They're the only two that fit in the range. All right, here we're going to be looking at tangent 2x is equal to -1. So when is tangent equal to -1? Well, here so we have 1 and -1, and down here. Okay, so this angle here, we know that this is pi, and we are above it, therefore we're going to subtract. We know that when these two are 1s, that means this is really a √2. It means that we're talking about 45-degree angles, or pi over 4s. So this is going to be pi, subtract out pi over 4, which leaves me 3 pi over 4. Down here this is 2 pi, and we're below, so that means we're going to subtract out another pi over 4. That means I have 7 pi over 4. But I have to go around a second time. So I'm taking 2 pi over 4, going over to here. 2 pi plus 3 pi over 4. That gives me 11 pi over 4. And just to show you what I mean, we have 3 pi over 4 plus we're adding a 2 pi. Well, 2 pi in terms of fourths, we get a common denominator. I get 8 pi over 4. Remember, this is 1, multiply bottom and top by 4, and then add them together, I get 11 pi over 4. I now have to add 2 pi over 4 with my 7 pi over 4. That's going to give me 15 pi over 4. Now, we're talking about double angle, therefore I have to cut all of these in half. So I multiply them all by 1 over 2. Top with top, bottom with bottom. That leaves me with 3 pi over 8, 7 pi over 8, 11 pi over 8, and 15 pi over 8. And these are my 4 angles. And all of these work because they all fit within the range. Really, if I want to talk about 8s, this would be 16 pi over 8. 16 divided by 8 is 2. And this biggest one is 15 and 8, which means it fits right below the top of this range. All right, 1, 2, 3, 4, 5 problems left. And we can call this video done as well. Okay, if equations involve mixtures of angles, meaning if you have x and then 2x, or x and x over 2, we have to substitute using the double angle or half angle formulas to get it in terms of one angle. What that means is that in case of number 7, I have cosine 2x and then cosine x. I want to get this in either both of them being 2x's or both of them being x's, preferably them both being x, because it just makes life a little simpler. What that means is that this cosine 2x, I can replace that using my double angle formulas on your formula sheet from chapter 5. Yes, you are permitted to use your formula sheet for the next test. So cosine 2x, I know that is 2 cosine squared x minus 1. That's the substitution, and then continue out the rest of the equation. Minus cosine of x equals 0. Well, what I'm going to do is I'm going to rearrange this to be 2 cosine squared x minus cosine x minus 1. I like it in descending order because when it looks like this, I can clearly see these factors. into 2 cosine x plus 1 and cosine x minus 1. Remember that if you ever get stuck with factoring these, you can change them to be purely algebraic. If you can factor this much easier, then do so, and then just replace the x's with cosines. Alright, so here I need to know that cosine of x is equal to negative 1/2. And over here I need to know when cosine of x is equal to 1. Alright, when is cosine x equal to negative 1/2? That's 120 degrees and 240 degrees. When is cosine of x equal to 1? There's only one place that is, and that is 0. So my answer is 0, 120, don't forget our degree symbols, 240 degrees. Now, I do not have to double these, I do not have to cut them in half, because when I solved the equation, I wasn't in terms of double x's. Okay, I was in terms of single x's, which means I don't double it, I'm just solving for whatever I get, which is why I said at the beginning, instead of trying to make both of these be double x's, get them into single x's. So when you solve, whatever you get, you're done. Okay? Cosine of x equal cosine squared of x over 2. I'm going to rewrite it. So now, this cosine x over 2, I can do a replacement, or a substitution. I know that that is really the square root of 1 plus cosine x over 2 squared. So cosine x over 2 is the root of 1 plus cosine x all over 2, all under the radical. And then since it was cosine squared, I have the square outside. Square and radical cancel, leaving me with cosine of x is equal to 1 plus cosine x over 2. I am going to multiply both sides by 2. By doing so, I'll cancel out this fraction. So I have 2 cosine x is equal to 1 plus cosine of x. I'm going to subtract cosine. So I get that cosine of x is equal to 1. And when is the only time that cosine x is equal to 1? It's at 0. Or 2 pi. But we're talking about in terms of degrees, and we can only go to 360, and we cannot be equal to 360. Alright, these last few, I'm just going to give you the answers to them because it wants you to just plug them into your calculator. Remember, this is y1, this is y2. Same thing down here. This is y1, that's y2, y1, and y2. And I'll show you how to do one of these on the Desmos, but for your answers, you're going to do in terms of radians. And I'm going to give you them in terms for number 1. Since it's weird, it's in 1/3. I'm going to go ahead and give it to you in decimal, which means it can't exceed 6.28. So we have 0.365, 1.206, 3.506, and 4.348. Okay, so that is the first one. That's number 9. With number 10 and number 11, you have 2 pi over 3, 4 pi over 3. That's for number 10, part A. 10, part B, you've got pi over 4, pi over 2, 5 pi over 4, and 3 pi over 2. Alright, now let me show you what that looks like in Desmos. So if I have sine cosine x, and I want this to be 1 divided by 3. And if you are using Desmos, you will have to put parentheses around this, because what it does is it thinks you're saying sine x cosine x, all inside the sine function. So here, I go across, I've got 0.365, 1.206, 3.506, and 4.348. Okay, for the second one, we're going to do 2 sine of x divided by 2. And we want that to be equal to, here, root 3. We can see we only have 2 spots. It gives it to you in radian form, 2 pi over 3, 4 pi over 3. And the last one, we have sine of 2x, and we have 2 parentheses cosine of x quantity squared. Okay, so sine 2x is the black, the cosine is the red, pi over 4, pi over 2, we're looking just for where they intersect, 5 pi over 4, 3 pi over 2, and then at this point, here's your 6.02, there's your 2 pi there, so that's the mark where it has to stop, and they don't intersect beyond that point until they get here, which is 9 pi over 4, and it's outside of our range. Okay, well that's it for 6.3. Next video will be 6.1.